Hello viewers, in today's class we are going to solve yet another very important and conceptual problem from definite integrals, right? So here we are going to solve this integral that is from 0 to 2, and here we have the fractional part of x and e raised to greatest integer of x, right? So we have to solve this integral, and here we see that our integrand is a mixture of or a combination of fractional part function and greatest integer function, right? So when we solve this integral, we have to take care of both type of functions, that is the fractional part function and the greatest integer function, right? So this curly bracket shows the fractional part function, and the square brackets shows the greatest integer function, right? So let us start. Now let us first call this integral as I, right? Now here what we do whenever we see this type of integral, then we have to make use of the definitions of different types of functions, right? So here we have fractional part function and greatest integer function. So let us first take the fractional part function, right? So we have the fractional part of x, which is defined as x minus greatest integer of x, right? So this is the definition of fractional part function, and we know that the domain of the fractional part function is the set of real numbers, and the range of fractional part function is the interval from 0 to 1, right? So this is half closed and half open. So this can also be written as x greater than or equal to 0 but less than 1. So this is the range of fractional part function. So here if we replace the fractional part of x by x minus greatest integer of x, we get 0 to 2, and here we have x minus greatest integer of x and e raised to greatest integer of x, right? Okay, so now we see that our integrand is now consists of only the greatest integer function, and the limits of integration are from x is equal to 0 to x is equal to 2, right? So here we have 0, here we have 2, and between 0 and 2 we have the integer 1, right? So since we have the greatest integer function here, so we have to break this limit at this integer point, right? So this integral point, that is x is equal to 1, is the breaking point where we have to divide, or we have to split this integral as a sum of two integrals, right? That is I1 and I2. So I1 is from 0 to 1 and I2 is from 1 to 2, right? So when we have 0 to 1, we have x minus greatest integer of x and e raised to greatest integer of x dx, and here also we have x minus greatest integer of x and e raised to greatest integer of x, right? Okay, so now let us assign the value for this greatest integer function x. See here x varies from 0 to 1, right? So when x lies between 0 and 1, then obviously the value of greatest integer x is equal to 0. So this is due to the definition of greatest integer function, right? And when x varies from 1 to 2, that is x lies between 1 and 2, then the value of greatest integer x is equal to 1, right? So here we'll take greatest integer of x as 0, and here we'll take greatest integer of x is equal to 1, right? So now we have 0 to 1, so we have x minus 0, and we have e raised to 0 dx, and I2 is 1 to 2, we have x minus 1 and e raised to 1 dx, right? And we know that e raised to 0 is 1, so we have 0 to 1, and we have simply here x, right? So we have the integral from 0 to 1 x dx, and here we have 1 to 2, and we can take this e outside, so we have e and x minus 1 dx, right? So now we have these two simple integrals to evaluate. So now the value of I is equal to, here we have x square over 2, the integral of x, and limits are 0 to 1, and here we have e, and here we have x square over 2 minus x, and limits are from 1 to 2, right? Now we'll simply substitute the limits and we'll take the difference. So when we take x is equal to 1, we have 1 square, that is 1 over 2 minus 0, and here we have e, and when we take 2, we have 2 square is 4 over 2 minus 2, then we have 1 over 2 minus 1, right? So this is half, and this is e, and here we have 2 to the 4, 2 minus 2 is 0, and here we have half minus 1 is minus half, right? And this is half plus e times half, right? So this is half 1 plus e, or e plus 1 over 2, right? So viewers, the value of this definite integral is e plus 1 over 2, where e is the famous exponential number which lies between 2 and 3, right? So this is how we solve this integral.